The skull, now known simply by its museum classification number, 1470, seemed to have fulfilled his life's quest, to find the fossil of the ape with the big brain, the fossil that seemed to prove humans had evolved in their special way because of the early development of their intelligence. 1470 was a sensation, reconstructed all over the world so that everyone could gaze upon this crucial human ancestor. It became more than just a fossil, but an icon, because here seemed to be proof of what had always seemed so obvious, that it must be our superior intelligence that had set us apart from all other animals, and the first key evolutionary change that had begun it all must have been the development of the big brain.
So here seemed to be evidence for what you can think of as the sort of brain-led theory of human evolution, that we have a large brain early on in the course of human evolution, and in a sense, once you have a large brain, everything else is inevitable, and this seemed to show exactly that pattern.
It now seemed beyond doubt that human beings had evolved in their unique way because of the big brain. But this whole theory was about to be proved wrong. The triumph of Leakey and 1470 was to be short-lived. In 1974, a young American researcher called Don Johanson was hard at it in the field, looking in rocks that were about the same age as 1470.
I was out surveying in the morning with one of my graduate students, Tom Gray, and as we were walking back to the Land Rover, it was now noontime, and it was close to 110 degrees, and it was time to head back to camp. I happened to glance over my shoulder, and as I looked down, I spotted this piece of bone, a little piece of elbow. And as I looked up this slope, a very gradual slope, I saw, glistening in that sunlight, other pieces of bone.
They had stumbled upon almost the entire skeleton of a 3-million-year-old ape-like creature.
Here was a specimen that was astonishingly complete, something that really literally had never been found before.
Round the campfire, they christened their new discovery.
One night when we were celebrating, we were listening to a Beatles tape, and on that tape, Lucy in the Sky with Diamonds was playing, and a member of the expedition said, "Well, why don't we just call the skeleton Lucy?"
Back in America, they began to analyze Lucy. She was classified as an Australopithecine, an ape-like creature, and was dated at about 3.2 million years old, just older than 1470. But then, as they slowly put the bones together, there came proof that she really was a human ancestor. Because this ape-like creature had one clear human characteristic, and it wasn't a big brain, but something quite different. She seemed to walk in a way that only humans do. Lucy was, as scientists say, bipedal, unlike apes who are quadrupedal. She walked on 2 legs, not 4.
Fortunately, we had most of her pelvis preserved, which of course is a critical part in terms of how an animal locomotes. For example, a quadrupedal, a 4-legged chimpanzee, this example, for example, is very different from what we see in Lucy's pelvis. And in many respects, not identical, but in many aspects, Lucy's pelvis reminds us of our own. Here is a pelvis of a modern human walking on 2 legs, and the similarities are quite striking.
No mammals, apart from humans, have ever walked on 2 legs. And there was more. They found Lucy's footprints. The fossilized Laetoli footprints were discovered in northern Tanzania in 1976. They are 3.6 million years old, almost the same age as Lucy, and were just the same size as her feet. They seem to confirm that Australopithecines like Lucy had walked on two legs.
We're looking at the soft anatomy of early human ancestors who walked across a volcanic ash and left an impression of what their feet looked like. We see that their feet were shaped just like ours, that they walked around in a manner that was almost identical to ourselves.
If Lucy had walked on two legs, then it seemed she had to have been a human ancestor. And that's when the trouble started, because Lucy's brain was just too small.
Fortunately, we had the very back portion of the skull preserved. And you can tell from the curvature and the size of a brain that would have fitted in there that it was about the size of an American softball, which means about a third to a fourth the size of a modern human brain. So this was a creature with an ape-sized brain, very different from our own.
There was now a huge problem. Only one of Lucy and 1470 could be our ancestor. Both were about 3 million years old, but each had different characteristics unique to humans. If the theory was right, and it really had been the development of our masterful intelligence that had led us to evolve from apes, then that ancestor had to be the big-brained 1470. But now there was real doubt.
The signal that was coming out of these fossils was difficult to interpret, because on the one hand you had 1470 with its very large brain, and on the other hand you had Lucy with a very small brain, but clearly bipedal. And so what we then had was really a period of conflict.
The only compromise, that somehow the slightly older Lucy had evolved into 1470, was also ruled out. 1470's brain was twice the size of Lucy's. There was no way any creature could have doubled its brain size in the 400,000 years that separated them. The conflict was resolved brutally. 1470 and Lucy were dated again, using radioactive dating techniques. Both had been found between layers of volcanic rocks, and volcanoes produce radioactive minerals when they erupt. Over time, these minerals decay. By working out how far this decaying process had gone, they calculated the age of the rocks in which the fossils were found. The result would change everything. Two-legged Lucy was just over 3 million years old, but Big Brain 1470 was more than 1 million years younger, less than 2 million years old. The Leakeys had blundered. The difference was such that 1470 could be descended from Lucy, and that meant the fossil of an ape-like creature with the first key human characteristic was not the big-brained 1470, but the two-legged, small-brained Lucy. The big-brain theory was now officially in the bin. Instead, hard though it was to believe, it was now clear that the first key human evolutionary development that had set human beings on their unique evolutionary path was that we had walked on two legs.
It basically killed the old idea that the earliest ancestors would have a big brain, because now we realize that bipedalism must have led into later ancestors with the larger brain size.
Lucy now became the great iconic fossil, the creature that held the key to why human beings were so much more intelligent than all other animals. Though it was hard to see why walking on two legs had somehow made us the most intelligent beings on the planet. Why intelligence should have evolved from moving on two legs doesn't seem obvious. So now a theory had to be devised to explain how bipedalism had let us evolve into the most amazing creature on the planet.
We suffer from back pain, fallen arches, hernias. We're very slow. We're one of the slowest mammals around. Think about the fact that here was a little 3.5-foot tall Lucy walking around with lots of hungry carnivores. She couldn't outrun a house cat. So the advantages of bipedalism must have far outweighed the disadvantages.
But then it all became clear to anthropologists. Stage one was that by standing up, our front legs became hands.
When our ancestors stood up, they could begin to use their hands to carry things, to make and use stone tools, to manipulate things, to use them in ways that quadrupeds don't.
Tools led to early technology. Technology to more ways of getting food. Better diet fed bigger brains.
This had enormous consequences for things like social organization and language, and that this was then the stimulus for the development of larger brains.
Larger brains led to primitive culture and new ways of communicating. Better communication led to more complex societies to more advanced cultures, and even bigger brains. And so it went on for millions of years. So there were ways in which two legs could lead to mankind's ancestors developing bigger brains. It seemed we had evolved into the most intelligent of all animals for one simple, crucial reason. Because millions of years ago, Australopithecines like Lucy walked on two legs. But there seemed to be something even more extraordinary about Lucy, something so remarkable that it confirmed what many had long believed, that in some strange evolutionary way, we really were unique. Because it began to seem that Lucy's species, alone of all creatures, had defied the laws of evolution. Lucy's species should have evolved according to laws of evolution which state that major evolutionary events occur when there is a sudden and dramatic environmental change. Those who cannot adapt to the new world die. But some animals will have a chance mutation that may help them survive in the new environment. These survivors will form the basis of a new species. Slowly, these new species will start to exploit all the different ecological niches in the new environment. Gradually, these creatures will adapt to these different niches, and slowly one new species will evolve into two.
We can see how this happens where something new arises, there's a new adaptation, a slightly better way of getting hold of food, of avoiding a predator, of walking across a landscape, and that then gives that population an advantage. It spreads out into new areas. Where you had one population, you now have two. Where you have one species, you now have two species.
This is how evolutionary family trees develop. Two species split to form separate branches. These branches can split again, and then again. And so a whole host of related species will develop.
So what is happening is that each time you're getting proliferation of branches, you're getting divergence taking place, and with that divergence comes what we think of as an adaptive radiation.
Adaptive radiation is one of the fundamental truths of evolution. There are signs of it in virtually every type of animal that has ever lived. Like the cat family.
The cats are a beautiful example of an adaptive radiation because you can see what they all have in common. They have in common the fact that they are hunters and stalking hunters, and they have diversified from a common ancestor into everything from lions, which are very large, to wild cats and lynxes that can live in cold environments, to indeed domestic cats today. So they are a beautiful example of this, the shape of evolution.
Adaptive radiation has given cats a classic evolutionary family tree. lots of related species coming from lots of different branches. It means the cat family tree